66 million years ago, a fiery asteroid struck Earth and ended the reign of the dinosaurs. But their story is far bigger than a single catastrophe. For over 160 million years, dinosaurs lived through climates far hotter, wetter, and more extreme than our own. They endured volcanic winters, sweltering greenhouse atmospheres, rising seas, and sudden shocks that reshaped the planet. Their rise, survival, and extinction are not just tales of prehistoric beasts, they are lessons about how life responds to a changing Earth. During the Triassic, Jurassic, and Cretaceous periods, carbon dioxide levels soared to 4 to 6 times higher than today. No permanent polar ice caps existed. Tropical forests reached the poles, and sea levels rose up to 200 meters, flooding vast lowlands. Dinosaurs adapted to this watery, swamp-like world, evolving into a stunning diversity of forms, from towering sauropods to nimble, feathered hunters. But thriving didn't mean the world stayed stable. Volcanic eruptions from splitting continents pumped more carbon dioxide into the atmosphere. Temperatures spiked, oceans warmed, and ecosystems shifted repeatedly. Some reptilian lineages vanished while others flourished. Traits like warm-bloodedness, insulating feathers, and flexible diets gave dinosaurs an edge, showing that life can survive dramatic swings in climate, though never without consequences. The first great lesson: rising temperatures don't simply destroy life, they transform it. Ecosystems reorganize, food chains shift, and only adaptable species endure. For dinosaurs, this meant evolving feathers, faster reproduction, and the ability to live in both tropical heat and polar twilight. For us, the question is whether humanity can adapt as quickly as they did. Some of the most revealing dinosaur stories come not from steaming jungles, but from the poles. In the Cretaceous, Alaska and Antarctica supported entire dinosaur ecosystems despite near-freezing temperatures and months of darkness. In Antarctica, predators like Cryolophosaurus stalked fern-filled valleys under long winter nights. Fossilized forests show dense stands of trees where glaciers now dominate. In Alaska's Prince Creek Formation, duck-billed hadrosaurs, horned ceratopsians, and small raptor-like trudentids nested permanently in the Arctic Circle. How did they survive? For years, scientists debated whether polar dinosaurs migrated south to escape winter. But juvenile fossils too small for long migrations suggest they stayed put. Some grew insulating feathers to hold warmth, while others may have slowed their metabolisms, entering near hibernation during dark, food-scarce months. These adaptations reveal that life is far more flexible than we imagine, yet such ecosystems were fragile, finely balanced against seasonal rhythms. Even small disruptions, whether warming, cooling, or volcanic darkness, could topple entire food chains. This is a warning for us. Modern coral reefs, tundras, and rainforests are our equivalent of those polar environments, beautiful, diverse, but vulnerable. When climate shifts, these systems collapse first, sending ripples through the rest of the planet. The reign of the dinosaurs was long, but far from smooth. Their history was punctuated by moments of crisis when the Earth's climate shifted so violently that entire ecosystems collapsed. These mass extinctions hold some of the clearest warnings for us today. At the end of the Triassic period, about 201 million years ago, enormous volcanic eruptions split apart the supercontinent Pangaea. Lava flows covered vast regions, and billions of tons of carbon dioxide poured into the air. Temperatures spiked, oceans acidified, and many great reptilian lineages, from crocodile-like archosaurs to large amphibians, disappeared. Dinosaurs, small and adaptable at the time, took advantage of the opening and rose to dominance. The most famous extinction came much later, at the end of the Cretaceous period. A 6-mile-wide asteroid slammed into what is now Mexico's Yucatan Peninsula, unleashing earthquakes, tsunamis, and wildfires. Even more devastating than the impact itself was what followed. Dust and aerosols blocked out the sun for years, plunging Earth into freezing darkness and collapsing food chains. When the skies finally cleared, carbon dioxide from vaporized rock and wildfires triggered extreme greenhouse warming, swinging the planet from deep cold to intense heat in a geological instant. Dinosaurs, which had already survived volcanic winters and millions of years of environmental change, could not withstand this double blow. In just a few thousand years, a blink of geological time, all non-avian dinosaurs were gone. These events show that climate change is not always slow and steady. Sometimes it is sudden, catastrophic, and irreversible. Life can adapt to gradual shifts, but when changes happen too fast, even the mightiest creatures are brought down. Another key feature of the dinosaur world was water. Rising seas shaped continents, drowned lowlands, and forced species to adapt to disappearing habitats. At the peak of the Cretaceous, sea levels were up to 200 meters higher than today. Whole regions of North America lay beneath a shallow inland ocean called the Western Interior Seaway. From the Gulf of Mexico to the Arctic, this vast sea teemed with plesiosaurs, mosasaurs, and giant fish, while coastal floodplains supported hadrosaurs, ceratopsians, and Tyrannosaurus rex. High seas created both opportunities and risks. Dinosaurs adapted to new wetlands, swamps, and coastal forests, while predators and flying reptiles evolved to hunt in shifting environments. In North Africa, Spinosaurus even took on a semi-aquatic lifestyle, diving into rivers in search of fish. Yet rising waters also erased entire habitats, forcing migrations, extinctions, and evolutionary leaps. Species unable to adapt quickly disappeared. Today we face a similar transformation, but on a human timescale. Modern sea levels are rising at a pace that will redraw coastlines, submerge islands, and flood low-lying cities. For dinosaurs, such changes unfolded over millions of years. For humanity, the same scale of change is happening within centuries. The difference isn't magnitude, it's speed. When the asteroid struck 66 million years ago, it didn't wipe the slate entirely clean. While most dinosaurs perished, one lineage survived: birds. Every sparrow, penguin, and eagle alive today is a living dinosaur, the last branch of a family tree once filled with giants. This is perhaps the greatest lesson dinosaurs give us about climate change. Their world was constantly reshaped. Their story proves that life can be astonishingly flexible when faced with environmental turmoil. But their downfall is just as important. The clearest warning they leave us is that resilience has limits. Today, we are living through a transformation of similar scale, but on an even faster timeline. Carbon dioxide is rising at a pace unseen since the great volcanic events of the past. Temperatures climb, oceans swell, and ecosystems strain under pressure, not from tectonic forces or asteroids, but from human activity. What took millions of years in the Mesozoic is happening now in mere centuries. Thank you for joining me on this journey into the lessons dinosaurs teach us about climate change. If you enjoyed exploring this prehistoric world, make sure to subscribe because we have many more mysteries of the deep past still to uncover. Until next time, stay curious and remember, the past is never really gone. It still speaks if we're willing to listen. Bye.